And reading here, a distribution company produces its product at 2 different factories. First line, 50 units at F1 and 40 units at F2. So we have 2 places, factory 1 and factory 2, where we make things to meet a demand for its product at its 2 warehouses. So there's a demand of 30 units at W1 and 60 units at W2. Before we read any further, we can start to translate this prose into a diagram. And after we have the diagram, we will not need the prose anymore. We'll have a node for the factory 1 and a node for factory 2. And we can show the 50 units coming in. So there's 50 units coming into F1 and 40 units coming into F2. And ultimately, this is required. Add 2 nodes, W1 and W2. And W1 requires 30 units and W2 requires 60 units. So 30 units at W1, 60 units at W2. So we'll show this as withdrawals. And notice that the total of the 30 and 60 is equal to the total of 50 and 40. So there's a balance in this network. Now, sometimes via a distribution center DC, so there is a distribution center DC. From F1, it costs $900 per unit to ship to W1. From F1 to ship to W1. So we are going to ship to W1. Now there's some qualifying data that it costs. Now every arc, we will have a rule. Every arc gets labeled with 3 different quantities. The flow has to be between a lower bound, and then a slash, an upper bound, a slash, and then some cost information. So if we take this arc from F1 to W1, we're going to label it as 0 as the lower bound, infinity as the upper bound, because there is no bound given. And it costs $900 per unit that flows along here. So we have added all the information for the flow from F1 to W1. So from F1, it costs $900 per unit to ship to W1, $400 per unit to ship to DC. So here we have 0, infinity, 400, and $200 per unit up to 10 units. So here we have an upper bound to ship to F2. So we can show this 0 and a maximum of 10, and it costs 200. From F2, the units can only be shipped to DC at a cost of $300 per unit. So from F2, they can only go to DC at 300. So 0, infinity, 300. From DC, a maximum of 80 units can be shipped to W2. From DC, a maximum of 80 units can be shipped to W2 at a cost of $100 per unit. In addition, units can be shipped from W1 to W2 at $300 per unit. So 0, infinity, 300. And from W2 to W1, they can be shipped at 0, infinity, 200. How should the goods be shipped to minimize transportation costs? So we have to record somewhere that this is a minimization problem. We have to remember that. So this description that we have here is below the prose is a translation from text into a graph. And that's where the challenge lies in these problems, is how to find the diagram that properly represents the prose. That's the formulation part. So now that we've done this example, let's move next to how should we go about solving this problem.